This lesson is on obtuse angles and the Cartesian plane. Obtuse angles are angles which are between 90 degrees and 180 degrees. So far what we've been working with is acute angles, which are angles that are between 0 and 90 degrees. So now we're going to learn about how to work with these angles that are slightly larger, cannot be in a triangle. Cartesian plane, keep in mind, that's just another fancy word for your x and y axis. Your x and your y axis, we technically call that the Cartesian plane. So an angle measured in, we call it standard position. Measured in standard position is measured counterclockwise, so in this direction, about the origin from the positive x-axis on the Cartesian plane. Primary trig ratios of an angle in standard position are defined in terms of the coordinates of a point, so x and y, on the terminal arm. That's a lot of terminology. So if we take a look, first of all, at the standard position, so we always start for standard position, we start with this arm, and we call that the initial arm. The angle is then the angle created from this line around to point where we've stopped our line. So this is the terminal arm. So if we are going to look at the primary trig ratios, so the primary trig ratios, remember, are just sine, cosine, and tangent. We want to talk about these in terms of the x and y values on the Cartesian plane, because that'll help us work with these slightly bigger angles. So this angle you can see here is larger than 90, less than 180. This is an acute angle. So this angle is within the 0 to 90 degree range. We can use this method on the Cartesian plane for angles that are acute. So this is an acute angle, and it is in standard position. Oh, that's written here. And this is an obtuse angle in standard position. So if we want to look at sine of an angle, this is my x value. So remember, the x value is how far along this axis we've gone. So if we look at this one, do this one first. This is my x value. Okay. From that point, this would be the x value, and this would be the y value. And we still call this is still the hypotenuse, but for this purpose, we're going to start using the letter R. And that's going to become apparent soon. I'm going to use the letter R to represent the radius. Keep in mind, the triangle is always drawn no matter which line we draw, but for the terminal arm, we always use the triangle that connects to the x-axis. So the line always goes straight down. We never really, just to give you what we don't do, so say I had an angle between 90 and 180, so say my terminal arm was here, which means that this is my angle. I would never draw my triangle like this. Not in this course, at least, okay? Don't do that. We always draw it. That was my arm. We always draw the arm straight down. If you don't do this and you do this way, you're going to get your, if you use these formulas, you're going to get them mixed up. So we always draw it straight down to the line. So sine, this is x, y, and r. So sine of theta, sine of an angle, would be the opposite. So remember, we can write down our SOHCAHTOA. Sine is opposite, so the opposite to this would be the y value divided by the hypotenuse. And that works for both of them, opposite, hypotenuse. Cosine would be our x value, the adjacent, divided by r. And tangent would be y divided by x. Now if you take a look at this, r is equal to the square root of x squared plus y squared. That's just if we were going to solve for this using our Pythagorean theorem. This is the formula we would get. So we don't have to write r. We can always talk about r in terms of x and y. So the square root of x squared plus y squared would be this side length. So we can talk about all of our ratios in terms of x and y. This is just some terminology. Quadrant 1 is this quadrant here. It is our acute angle. Both x and y are positive in this quadrant. Quadrant 2, so this one's 1, this one's 2, 3, 4. Quadrant 2 is our obtuse angle. So if we're in quadrant 2, then we're dealing with an angle between 90 and 180 degrees. The only thing that's different about this is the x value in this quadrant is negative. So we have to be super careful with that negative when we're calculating our trig ratios. Some of our ratios, basically any of our ratios that involve x, so cosine involves x, tangent involves x, will be in this quadrant, it will be negative. So if your angle is obtuse, your ratio will be negative.